all data science learners. Today we are again with another video of our data science series, and today we will be learning about data preparation phase to model the data. So let's start with it. So first of all, we will be seeing that how to partition our data. That is how to split our data into training data set and test data set. So what is a training data set can be compared easily for easily understandability. We can compare it to students test textbook when learning a new subject, and the learners learns by reading the text and completing the task, and book offers all the knowledge they require. And testing data is compared to exam. A student takes to determine how well versed in a subject they are. So for training for this partitioning, we will be using sklearn library. So first of all, we are importing all the required libraries, and here we will be using iris dataset. So I have loaded the iris dataset. So iris dataset is basically of sepal width, petal width, and sepal length, and the target variable that what variable what we have to classify is there in the form of 0 1 2 and 3 as the output. So first of all, we are separating the independent feature and dependent feature. So what is independent feature and dependent feature? The independent features are all those features which are independent of each other. Basically, are those features from with the help of with we will be getting our classifying data means जो डाटा अपने को चाहिए मेनली बेसिकली अपने को जो क्लासिफाई करना है वो इसकी इसकी हेल्प से अपन क्लासिफाई करेंगे. एंड डिपेंडेंट फीचर इज that these all independent features will be dependent on this dependent feature for our classifying output. So let's run it, and I have count for counting the uh, values of our target variable. I have run a command. So we are having 0 1 and 2 as outputs and target variable, and all are counting to be 50. So it is a balanced data set. So let's move to the trend test split. So in this trend test split, I have passed four parameters: xtrain, xtest, ytrain, ytest. So xtrain will contain all the independent training data set, and xtest will contain all the dependent training test data set, and ytrain will contain all the independent train data set, and ytest will contain all the dependent dataset for the test case. So this is, and I have passed x and y as parameter, and test size will be 0.2. Basically it means that 20% of whole data will be uh, granted to test. So let's run it. So we have successfully partitioned our data using train test split. So you can see that x train. So what is extend? So it is containing all the independent features: sepal length, sepal width, petal length, and petal width. And what is X test? So X test will also contain the independent feature only. And what is Y train? Y test basically. So test is containing all the target variable. This is 0, 2, and 1. So now if the data is not balanced, so what we have to do? So for this we have to balance the data, because if the data is not balanced, so our output may truncated. Suppose that there are 1 lakh credit card transaction data we are having, and from that data 1000 credit cards are transactions are classified as fraud in the training data. So our classifying model will be the 90% accurate by predicting that the transactions are not fraud, but this model is useless. So our data must be balanced so that there must not be any truncating error or partiality, basically you can say. So I have a file, read the file, then in this data set, we are having feature 1 and feature 2 and target. In target we are having 0 and 1 is our output. So let's see the value count. So we are having 0 in the number of 900 and 1 is 100. So here we are having unbalanced data. So for balancing it, I have created a variable df underscore minority. It will contain all the data from the df data set which are equal to 1, and the df majority will contain the data which are giving output as 0. So from sklearn.utils I have imported resample method. In resample method we will be passing df minority, means which is in minority we are passing, and then we are passing number of samples we need to resample to get our um, data balanced. So for this I have passed the length of the majority uh, majority data, that is of 0, that is 900 basically length it is. So let's run it, and random state is 42, so successfully run. So now you can see that we will be seeing the shape of the df minority balance. So it is 900 into 3. 3 is basically 2 of features and 1 is of target, and 900 um total outcomes are there for 1. And then we are concatenating both the variables, and then now in the final df dot balanced data frame we are seeing the target value counts. So here we can see that 0 is also now 900 times and 1 is also 900 same. So thank you, and hope to see you all in the next video. Thank you. You are healthy or not. So if your age is greater than 40, then then there are two possible conditions, that it can be yes and no. If it is yes, then if you eat fast food, then again two decisions can be there, yes or no. Same in here case, if you does not do exercise, then yes or no. Then you are fit or unfit, it can classify it. So basically decision tree is used for classification problem. And for decision tree, two basic terms are there, entropy and Gini index. So entropy is the measure of purity of sub split. Entropy always lies between 0 to 1, and this is the formula for entropy, which is negative of positive probability into log 2 of positive probability minus negative probability into log of negative probability. And what is Gini index? So Gini index is the probability of misclassifying a randomly chosen element in a set, used for building the tree by splitting S per the appropriate feature. So entropy and Gini index is used for which root node we need to choose for our next uh, sub decision tree. And again, a new term is there, it is information gain. Information gain is the measure of change in entropy. So if the greatest the information gain feature will be selected for root node. The so formula for information gain is entropy s minus all the entropies of individual parameter into entropy of individual parameters, and this is the uh, total number of individual parameter. Below this the uh, all the number of individual parameters. So here we can see that so here in this decision tree, the eat fast food node is selected because it is having greatest information gain. So now let's move to the code. So decision trees of two types: card decision tree and C5.0 decision tree. In card decision tree, we use our criteria as Gini index for splitting, choosing the root node for the sub tree. So here I have imported the sklearn.tree decision tree classifier. In decision tree classifier, we are making a model decision tree classifier with the criteria Gini index. Then we are fitting our extend and Y-trend model, which we have splitted in previously. Then now let's run it. So we've successfully imported in this code and this also. Okay, we have not. So we have created it. Then we are visualizing the decision tree. So how this decision tree is made. So first of all, Gini index is calculated, and on the basis of Gini index, two more samples are taken, and likewise this decision tree is made. And now we are predicting the tree classifier. So and then and the second type of decision tree is C5O class C5.0 decision tree. In this we use criteria as entropy for splitting our subtree. So let's run all these commands. So first of all, we are importing the decision tree classifier. Then we are setting the criteria to entropy. Then again, same normal fitting extend and y10 on this model. And then again, we are using this code for visualizing it. So here the entropy is calculated, and on the basis of entropy, the sub root node for the other subtree is calculated. So here it is final, it is the leaf node, because there is no subtrees. And here this is having subtrees and sub decisions. So we are having again two decision tree. Then this both are this and this both are the leaf nodes. So this will all will predict the classified output. So then again, a new topic for this video is random forest classifier. So what is random forest classifier? So random forest classifier basically calculates uh, decision tree for many subdata in our data set. And then this tree uses test data to calculate which decision tree is appropriate for the data. So it reduces the performance and reduces the risk of overfitting. So it works by creating a number of decision trees during training phase. Each tree is constructed using a random subset of data set to measure a random subset of features in each partition. So in this decision tree, for this training data set, in this photo it is clear that uh, we are making class A, class B. So we are training this. These all are three different decision models, and on the basis of this decision model, we are then classified outputs. We are getting a voting. So suppose for a test data one, the class A says that it should be yes. The class B said it should be no, and again a class C said it is yes. So the majority is yes, so the predicted output will be yes. And for regression, random forest is also used for regression. For regression, we average out the output from all the decision tree, and it is the final output of the whole model. So for this, we are importing random classifier from sklearn.ensemble library. And then we are creating a model random forest classifier. Criteria is equal to Gini index. We are choosing the criteria, and n estimator is 100. Means the number of subsets of the dataset for different decision trees, and they are fitting this training model. So and we are predicting. Now in next video we will be moving to the model evaluation, in which we will be covering comparing the different decision trees, and also we'll be comparing random forest. So let's we will continue in next video. Thank you.